Hey Becca, what are we learning today?
Today, we're going to find the midpoint between 2 points. We're going to learn how to find the midpoint between 2 points on a coordinate plane. x1, y1 is our first point, and x2, y2 is our second point. The midpoint of these 2 points equals, it's a coordinate because we're looking for the coordinate that's in between point 1 and point 2. The x-coordinate is going to be the average of x1 and x2. So that is x1 plus x2 divided by 2 because we're adding two values together. So that's the average. And then the y-coordinate is simply the average of the y's. y1 plus y2 divided by 2. And this formula will give you the midpoint between point 1 and point 2. I'm going to show you a trivial example so that you see that the average of 2 points is the midpoint between them. Consider a number line, and we have 1 on the left side and 5 on the right side. And we want to know what the midpoint is between 1 and 5. If I count tick marks, 2, 3, 4, it's easy to see that the midpoint between 1 and 5 is 3 because it's 2 away from 1 and also 2 away from 5. But if we take the average between 1 and 5, 1 plus 5 divided by 2, that gives us 6 over 2, which equals 3. And that's our midpoint. So we're going to use the same type of calculation to find the midpoint between two coordinates by just taking the average of the x's and the average of the y's. Here's an example using 2 points on a two-dimensional coordinate plane. 1, 1, 1, 5. And we want to know what the midpoint is between these 2 points. The formula, we take the average of the x values, 1 plus 1 over 2, comma, and then we take the average of the y values, 1 plus 5 over 2. This is going to give us 2 over 2, comma, 6 over 2. And when we reduce those fractions, we get 1, 3. And that is the midpoint between 1, 1 and 1, 5. Here's an example using 2 points, but one of the points has negative numbers in it. The calculation stays exactly the same. The midpoint is the average of the x's, 2 plus negative 6 over 2, comma, average of the y's, 4 plus negative 10 over 2. Notice we still add the x's and the y's together, even though there's negatives in the equation. If we reduce this, 2 plus negative 6 is negative 4 over 2, comma, 4 plus negative 10, negative 6 over 2. And when we reduce this, negative 4 over 2 is just negative 2. And negative 6 over 2 is negative 3. Our midpoint between 2, 4 and negative 6, negative 10 is negative 2, negative 3. What happens if we try to find the midpoint in 3 dimensions? We have our x and y coordinates in the midpoint formula, but we don't have z. What do you think we're going to do to incorporate z? You guessed it. We're going to add it on to the end of the midpoint formula, the exact same way we did the x's and the y's. In 3 dimensions, we're just going to have the average of the x's, comma, the average of the y's, and the average of the z's. See how it's the exact same formula, but we just include the z's at the end. So let's try this example. The midpoint is going to be average of the x's, 2 plus negative 5 over 2, comma, average of the y's, 4 plus negative 10 over 2, comma, average of the z's, 7 plus 4 over 2. And if we reduce this, our first term, 2 plus negative 5 is negative 3 over 2. 4 plus negative 10 is negative 6. If we divide negative 6 by 2, we get negative 3. And our last term, 7 plus 4 is 11 over 2, which we'll leave as a fraction. And we have our midpoint of our two three-dimensional coordinate points. Now, if you have 2 points on a coordinate plane, you can find the exact midpoint between those 2 points. If you thought this video was helpful, you should definitely give it 2 thumbs up. And if you have any questions, leave them in the comments or shoot me an email. Make sure you subscribe, because we're posting new videos every Monday and Thursday. See you later!